Okay, so today is going to be just basically a repeat of the previous lesson. Had some computer issues with the last lesson that was posted, so this one should be a lot nicer and neater. This is section 4, which is all about calculating enthalpy. And the main idea with this whole section is you have equation A, you have equation B, and A and B combined form equation C. Well, in the problems that you can get in this class and on this topic is you'll be given C. But here's the problem with C. The change in enthalpy, you have no idea. You don't know. But what if I told you that when I give you A, and you will be given A, and when I give you B, that you will be given B, that A has an enthalpy change of, like, let's say 2 kilojoules, and B has an enthalpy change of -5 kilojoules, you can conclude that, well, our mystery is no longer a mystery. It's not going to be a question mark. It's going to be -3 kilojoules. That's what the point of this section is all about. Using the parts that make a whole equation to figure out what the change in enthalpy is for that big equation at the end. So this is Hess's law. Now, on the previous video, I defined Hess's law according to the textbook definition. Here's how I'm going to put it into my own words. If you can determine the change in enthalpy of 2 or more reactions that result in a final reaction, you can also determine that final reaction's enthalpy. All right, I'll let you guys get that caught up. And here's the equation that we are going to be working with on this topic. We have 2 moles of solid sulfur reacts with 3 moles of oxygen gas to yield 2 moles of sulfur trioxide gas, SO3. Now here's our issue. Here's the problem that we need to resolve. The change in enthalpy, we have no idea. We don't know. That's just, that little humming sound is from my plug. I'll try to maybe unplug it. Nick, you looked really scared when you heard that.
Something was being exploded.
Yeah, sometimes it does that. Hopefully my computer has enough power in it to not need power for right now. All right, back to this. So, guys, here we go. I will give you the 2 equations that will produce, or at least contain, solid sulfur, oxygen gas, and sulfur trioxide, okay? So here are the 2 equations. We're going to call them equations A and B. Equation A is as follows. Solid sulfur reacts with oxygen gas to yield sulfur dioxide. This change in enthalpy is -297 kilojoules. Is this an energy loss or an energy gain when you go from the reactants to the products? Gain, loss.
Loss, it's loss. I didn't see the negative.
Loss?
Yeah.
You're sure? So is it endothermic or exothermic? It's exothermic. If I have a graph like this, what would have more energy, the reactant side or the product side? You just told me it was a loss.
Reactant.
It'll look like this. What's this right here? Is that the reactants or the products?
Reactant.
That's the reactants. And this is the product. Okay. Monday, right?
I'm so sorry.
Okay, now, the other equation we will call B, and you will be given this. We have 2 moles of sulfur trioxide reacting with 2 moles of sulfur dioxide, reacts to form sulfur dioxide and 1 mole of oxygen gas. The change in enthalpy in this equation is 198 kilojoules. Is this reaction endothermic or exothermic? Think before you speak. Endo or exo? How do you know, Emma? There's no negative there. That's right. So does this mean an energy loss or an energy gain? Okay, so what has more energy, the reactants or the products? Good. It looks like this. Reactants, products. Nice. All right, so we're going to go back and forth, up and down, and we might have to do some things to these equations to eventually get it to look just like our equation up there in black, okay? So here's what I need you to do first. I want you to, this is what we did on the last lesson. I want you to underline anything in red, or at least if you don't have colors, I'll do it in red, that you see in our main equation, which is, whenever I say in the main equation, I'm referring to the one in black here, in our red equation, equation A. Do they both have sulfur? All right, so there we go. Do they both have oxygen? Yes. Do they both have sulfur trioxide? No. All right, so that's where they're different. Let's take a look at the equation B. Let's do the same thing. Do they both have sulfur trioxide? Yeah, right here. Do they both have sulfur dioxide? No. Do they both have oxygen? Yeah, there they are. Okay, so what I noticed first on equation A, guys, is how many sulfurs are there in equation A? 1. How many are there in our main equation? Good. How many oxygens are there in equation A? How many O2s? 1 O2. How many O2s are there in our main equation? 3. Now, here we have 2 sulfur dioxides, but sulfur dioxide is not part of this. So what I'm looking at here is we're going to have to change the coefficients a little bit, but we'll get to that momentarily. Let's take a look at B. B is way more obvious. I want you to identify that you all said that they both have sulfur trioxide, SO3. But Nick, what side of the equation is SO3 on our main equation?
Product.
It's a product. And what is it on B?
Reactant.
Now, how many moles of sulfur trioxide are there in the main equation?
2.
And how many are there on B?
2 moles.
So we don't need to adjust anything with the coefficients. What do we need to do with equation B in order to get it from the reactant side to the product side?
Flip it.
We have to flip it. So with equation B, this equation must be reversed. Or what Nick said is it needs to be flipped to have SO3 as a product. Why are we doing this? Because if you look at the main equation, SO3 is a product. So all I need you to do for this equation here, for B, is just write it in reverse. So here we go. Whatever was a product is a reactant, and whatever is a reactant is a product. Here's the new equation B. Now, something that year after year, I've taught chem for many years. Here's what students forget, and you guys are no different. You are not immune to this mistake. they forget to also flip the change in enthalpy. This was positive 198 kilojoules, but because we reversed it, what is the new value for the enthalpy change? Negative 198 kilojoules. So now our sulfur trioxide is a product, just like the main equation. That's good news. That looks great. Are there any questions so far? Yes? No? Okay. Well, what I want us to do is I want us to combine A and B. And I want you to notice something that we're going to have to do. So here's how I'm going to try to introduce this to you. We're going to combine A and B. Okay? But then we're going to have to go back and do something to A. And you might have an idea of what that's going to be. But I want you to look at our main equation. How many total sulfurs are there in the main equation? 2. How many total O2s are there? What's the coefficient in front of O2? 3. And what is coefficient of SO3? Okay, we have 2 here. That's great. Do we have 2 here? So that looks good. That looks good. I want you to check this out, though. Looking here. How many SO2s are here? There's 1. Is SO2 a reactant or a product? It's a product. Look here. How many SO2s are here? 2. Is it a reactant or a product? Okay. Do you see SO2 in our main equation? No, we do not. So what does this tell you is going to happen to SO2 when we combine equations A and B? It gets removed. It gets canceled out. But if we kept it at the current ratio, we have 1 SO2 here, and we have 2 SO2s here. Are they going to totally cancel each other out? They're not. So guys, what we need to do is we need to get that from 1 SO2 to 2 SO2s. And check this out. We also have to get that 1 sulfur to 2 sulfurs. So let's do that. Let's put a 2 in front of both of these. Let's just do that right now. You need to add a 2, or I should actually say double all species. So let's just say, time out for a second, you put a 2 in front of this and a 2 in front of that. Let me tell you why you're doing this. This is where it can get a little complicated. This is where we kind of got complicated on Friday. Check this out. Does this match up to this? 2 and 2? Look good? It looks good to me. Let's see. Is this going to cancel out with this? No. 2 and 2? Yeah. And does this, once again, match up with this? Yeah. Here's the problem I'm getting to, the oxygens. If we combine this oxygen with this oxygen, how many total oxygens would that be?
2.
That would be 2, Derek. Good. I want you to look at your main equation. How many total oxygens are there?
3.
That's not going to work, is it? So you need to put a 2 in front of that oxygen as well in equation A. There it is. Now, if we combine the oxygen from A and B, how many total oxygens will that be now?
3.
That will be 3. So what I would like you guys to do now is I want you to combine A and our new B together, and let's see what we can come up with. So let's write it all out here. So put all the reactants on one side and all the products on the other side. Here we are. 2 sulfurs react with 2 oxygen gases, react with 2 sulfur dioxides, reacts with 1 oxygen gas to yield 2 sulfur dioxides and 2 sulfur trioxides. Okay, here's what I want you to do. Combine any species that are on the same side and eliminate any species that are on opposite sides. Okay, guys. So here's what I'll do. I'll highlight anything in green that should stay, and then we'll cancel out anything that should go. Do you see anywhere else in this equation, the product or reactant that has sulfur? All right, so that gets to stay. Do you see anything that has oxygen? I see 2 moles of O2. I do see another O2. I see here and there. Are they on the same side or at opposite sides of the reaction? They're on the same side, so what should you do with those? Combine them. So what's 2 plus 1? We're going to now make this 3 oxygen. So pay attention. Here's what I'm going to do. I'm just going to erase this guy, get him out of the way, and I'm going to combine him over here. So this is now going to be 3 O2s. Do you see that? Okay. Do you see sulfur dioxide on the other side of the equation? How many? So this is gone, and this is gone. And then sulfur trioxide gets to stay. So you're going to bring everything down. Let's do that. We now have the same identical equation that we had at the beginning. And let's do our change in enthalpy. But there's one thing that we didn't do up top. We doubled everything for equation A, right? So what do we have to do with the enthalpy? You have to double that too. So times 2 is negative 594 kilojoules. Almost left that out. All right, so we have negative 594 plus negative 198. That should equal negative 792 kilojoules. We now have our mystery kilojoule total. And that is using Hess's law. So what I would like you all to do is I want you to open up your textbook. I want you to look in the index for unit on thermochem. And I want us to try to find a practice problem from the book. I'm going to pause the video. Okay, so we found our practice problem. We're going to do that now. Let's do it. Okay, so we have an equation. We have 2 moles of hydrogen peroxide yields 2 moles of water and 1 mole of oxygen gas. The change in enthalpy is unknown. We don't know. But we are given A and B equations, and we're probably going to have to manipulate them in some way, shape, or form. For the first equation, we have 2 moles of hydrogen gas reacts with 1 mole of oxygen gas to yield 2 moles of water. And then the second equation is 1 mole of hydrogen gas reacts with 1 mole of oxygen gas to yield 1 mole of hydrogen peroxide. And the change in enthalpy here is going to be negative 188 kilojoules. So Colby, I want you to take a look at equation A. Is that endothermic or exothermic? What is telling you that it is endothermic? Endo means it's being absorbed. If you are absorbing money, is that going to be a loss, Colby? You need to get that straight. Where it's a negative value, energy is being lost. Do you have a bank account? If you went online, you looked at your bank account, it said like negative $20. Does that mean you just gained 20 or you spent 20? You spent 20 bucks, so you no longer have it. It's a loss. Whenever there's a negative value in front of an energy value, a negative symbol in front of an energy value means that energy was lost. So tell me again, what is A? Exothermic. Max, what is B? Endothermic or exothermic?
Exothermic.
How can you tell?
Because it's negative.
Okay. And Nick, for both of those equations, these two boys said that it is exothermic. So what has more energy, the reactants or the products?
The reactant.
That's right. The products is the energy lost. Good. Okay, guys, I want you to take a look at our main equation. We have hydrogen peroxide as a reactant. We have water as a product and oxygen as a product. Which equation has our hydrogen peroxide? Equation A or equation B? B. Where do you see peroxide? It's a product side. So what do we need to do with B? Flip B. So do that now. Here's our flipped B equation. H2O2 is a liquid, by the way. Yields H2O and O2. What is the new enthalpy? You flipped it. How does it change? Kayla, how does the enthalpy change after we flip it? Currently in B, it's H2 plus O2. H2 plus O2 yields H2O2 with an enthalpy change of negative 188 kilojoules. What did we do to B to put the peroxide as a reactant? All right, we need to start over because I think you guys are just hearing me talk, you're not listening, and you're just focused on trying to write. I want to make sure you can make sense of this without me. Kayla, do you see H2O2 in the main reaction?
No.
Kayla, it's right there. The main reaction.
Oh, yes.
It's right there.
Yes.
I can't help you if you can't see. Which of the equations that were provided has H2O2, A or B?
B.
Okay. I want you to look at the main equation. Is H2O2 a reactant or a product? It is a reactant. Where is H2O2 on equation B? So what do we need to do with equation B? We need to flip it. So that's what we're going to do again. Now, Kayla, we flipped the equation. What else do we also have to flip? In all the years I've taught chemistry, this is what students forget to do the most. It was negative 188 kilojoules. Okay. You didn't say make it negative 188, did you?
No, I said it was negative.
All right. So now is this endothermic or exothermic? It's endothermic. Does that mean energy is being absorbed or energy is being released? Good. Now, Kayla, that's not all that we have to do to this equation. I want you to look at the main equation. How many moles of H2O2 are there? How many moles are there in equation B? So what do we need to do with the entire equation? It is already balanced, but if it's a 1-to-1-to-1 ratio, what would be no different? You need to double it. You need to double. If I double it, it's still going to be balanced. Why do we need to double it? To make it 2 H2O2. Do you see that? All right, so we need to, now, I'm going to tell you guys to double it. Still with me, Max? So the first thing you guys had to do is you had to flip it. Now you're going to double the equation. So we're going to have 2 H2O2, 2 H2, and 2 O2. So Kayla, this is your last question. If you doubled the entire equation, what else do you have to double? This is the number one thing that my students forget to do every single time we come up to this type of problem. You have to double the 188. So first you had to flip it. You went from negative to positive. Now you have to double it. So it's going to go from 188 to 376 kilojoules. Oop, not kilograms, kilojoules. All right, I think that we are done messing around with B. B looks pretty good. Let's take a look at A. Max. Let's see here. What parts do our main equation and equation A have in common? Like, what substances do they have in common?
O2 and H2O.
They have O2 and they have H2O. Okay. Where is H2O on the main equation? Is it a reactant or is it a product?
It's a product.
Okay. What is it on equation A?
Product.
Good. And where is oxygen on the main equation? A reactant or a product?
Product.
It is a product. And what is it in equation A? So here's the dilemma that we have. Oxygen is where it should be. It's a product on both the main equation and equation A. If you don't see that, I'll box it for you. Colby, do you see that water is a product? And you see here, what is it? So, and how many waters are there? And it's 2 there in the main equation. So I don't want to mess with that. But here's what I have a dilemma with. These oxygens. I don't want to flip it. So I want you guys to look at equation B. Do we have oxygen here? How many?
2.
Is it on the reactant or the product side?
Product.
Product. If I leave equation A the same, will oxygen cancel out?
No, there will be 1 left.
Your yes and no. Oxygen will cancel out, but it's going to be 2 versus 1, right? So you'll still have 1 left over. So do we need to do anything with equation A? I don't think we need to do anything. So what I would like you guys to do now is I want you to combine A and our new B after we flipped it and doubled it. So put all the reactants on one side, put all the products on the other side. So here's A, or excuse me, here's the combination of both. I'll put in all the parts for A first. 2 moles of hydrogen gas, 1 mole of oxygen, and 2 moles of hydrogen peroxide. And now I'm going to put all my products down. 2 moles of H2O and 2 moles of hydrogen gas and 2 moles of oxygen. Okay. John Dennis, I want you to tell me yes or no. I see hydrogen right here. Is hydrogen found anywhere else in this equation? Think and look before you speak. I want you to stop and think. Okay, where is it found? The reactant or product side? That's very good. It's right there. So do they combine or do they cancel? They cancel each other out. So I'm going to put a big fat X on both of them. They're gone. Emma, here I see oxygen. Do we see oxygen anywhere else in the equation?
Yes.
Where?
On the product side.
Now, Emma, do they have the same coefficient?
No.
No. So you have 2 on the product side, you have 1 on the reactant side. What will happen to the oxygen, the 1 oxygen on the reactant side?
It'll, leak.
So you're saying I'm going to combine them.
Yes.
They're on opposite sides, Emma. You do not combine them. They cancel them out. But here's what I'm trying to get you to realize. How many oxygens are there on the reactant side?
1.
And how many are on the product side? So what's going to happen to that 1 on the reactant side?
I don't know.
You have 1 on the reactant side, you have 2 on the product side. If you have the same substance on opposite sides of an equation, do they cancel out or do they combine? They cancel out. But when you have an uneven number, if you have 2 to 1, this oxygen is going to cancel out. And over here you have 2 oxygens. Let me visualize it for you like this. Look at this. Check this out. Maybe this might help you see it. Okay, Emma, watch. Does that help?
Yeah.
So let's say I have oxygen here and here, right? 1 and 1. What will happen to them?
They'll cancel out.
You said double and cancel out. You can't say both. That's what he did.
I'm just confused.
Are they on the same side or are they on opposite sides of the equation?
Opposites.
And whenever something is on the opposite side of an equation, do those substances cancel each other out or do they combine with each other?
Cancel.
They cancel out. You're sure? Yes. So how many oxygens are there on the reactant side?
One,
How many oxygens are there on the product side?
two,
So let's say I have this oxygen here and this oxygen here, 1 to 1. What will happen to them?
they'll go away.
They will go away. Okay? So gone and gone. Do we still have another oxygen on the product side? Yeah. So what I'm trying to show you here, Emma, is that there were 2 oxygens on the product side. One of those 2 is going to be eliminated because it's going to cancel out with the 1 that was on the reactant side. But you still have 1 left over. You get where I'm going with that?
Yeah.
So, you know, if my money cancels out your money, I have $2. You have $1. So here's my 2, here's your 1. Down goes your 1, down goes my 1. I still have how many left over?
One.
You get that how that works now?
Yeah.
Okay. Let's go to Kayla. Kayla, does anything else cancel out in this equation?
2, 8. Actually, no.
No. Good save. No, it does not. So I want you guys to rewrite the equation after we've canceled everything out. Is this identical to what we had at the very beginning? Is this our main equation? It is. So what is the last thing we need to do?
Get the,
We need to combine the enthalpies. Very good. So we need to combine 376 kilojoules from equation B. Remember, that's after we flipped it and we doubled it. And negative 572. That's from equation A. So if you guys can solve that. 376 plus negative 572. What'd you get?
negative 214.
Huh? I got something way different. 376 plus negative 572 is, did you guys get negative 196? That's what I got.
My calculator is that I'm not good at math.
Negative 196 kilojoules is the difference. So overall, what is this equation that we finally found the enthalpy for? Is it endothermic or exothermic? How do you know it's exothermic? Yeah, it's a negative value for the kilojoules. That's right. Okay. How much time we have left? We have 10 minutes. Let's do number 32 from your textbook. So I want you guys to help me out with 32. I do not know if this is a homework problem or not. I don't have all those memorized. This is number 32 from the textbook. We have 2 moles of carbon monoxide gas reacts with 2 moles of nitrogen monoxide gas to yield 2 moles of carbon dioxide gas and 1 mole of nitrogen gas. The enthalpy change is unknown. So for equation A, here's what we have. All right. There's our equations A and B. I think we can do this within 8 minutes. I would like you all to please take a look at equation A. What do A and our main equation have in common? Take a look and compare them and tell me what you find. What do A and our main equation have in common? Max?
The 2CO.
They both have 2 moles of CO, that's carbon monoxide. What else do they have in common?
The 2CO.
They both have 2 CO2s. Very good. Now, Max, you're right about the substances. Where are they located?
Both the COs are on the products.
No, they're not.
Reactant.
The reactant side is the left side, Max. And where is the CO2s?
Product side.
So do we need to flip A?
No.
No, it's not necessary to flip A because everything is where it should be. Good. Nick, what does our main equation and B have in common?
N2.
Okay, where is N2 on the B?
It's a reactant
And where is it on the main equation?
product.
All right, so what do you think we're going to have to do?
We're gonna have to flip.
We're probably going to have to flip it, but let's keep going. What else do they have in common?
They have 2 and O2.
It's not
2
two,
and O, sorry.
2 and O's.
Yeah.
Is it a reactant or a product?
It's on which one?
B.
B is a product.
And what is it on the main equation?
Reactant.
All right, so Max says we don't need to do anything with A, and I agree. Do we need to do anything with B?
Flip it.
Why do we need to flip it? There are students in this classroom that are not listening or they don't know why we have to flip it. Can you explain to them why we need to flip B?
So the N2 becomes a product and the 2NO becomes
So what Nick is saying
a
is
reactant.
here is nitrogen gas. It is a reactant. According to the main equation, it is a product. That's a problem. But at least it's N2. And then he also says over here, 2 moles of nitrogen monoxide is a product. But over here, it is a reactant. So Nick says we need to flip it. I agree. Let's flip it. And Nick, what else do we have to flip?
Negative to positive.
We have to change the enthalpy. So it's going to be negative. It's going to go from negative 180.6 to positive 180.6. Okay, I think we're good to go. Let's combine the 2 of them. Here we go, guys. This is the combined equation of A and B. Let's get all the reactants on one side and all the products on one side. All right, Emma, do you see CO, carbon monoxide, anywhere else in the reaction?
On the product side,
That's CO2.
so no.
No, so this is going to stay. John, do you see oxygen anywhere else in this equation? Okay, so how many moles of oxygen on the product side? How many moles of oxygen on the reactant side? So do they cancel out or combine? They cancel out. Bye-bye. They're gone. Okay, Kayla, do you see nitrogen monoxide anywhere else in the equation? No, so that gets to stay. And everything else gets to stay too. So let's just erase that oxygen, get it out of the way. Let's lasso this guy. Pull it over there. Is this equation now identical to the main equation? Yes, it is. So all we need to do now is just combine the enthalpies. So we have negative 566.0 kilojoules plus positive 180.6 kilojoules. Let's find out what that total is. Negative 566 plus 180.6. If you're not doing this now, why would you want to do it during the test? This is the practice. I got negative 385.4 kilojoules equals delta H. So is this equation endothermic or exothermic?
Exothermic.
It is exothermic. How can you tell?
Because of the negative.
That's right. All right.